So guys, in today's video, I'm telling you about the shortest paths in Python DSA. So yeah, I'm telling about that. So let's move to computer screen and let's do a coding with loving. So guys, in today's video of Python DSA, I'm telling you about shortest paths. So let's start and let's know about that. Shortest paths. Question. Write a function to find the length of the shortest path between two nodes in a weighted directed graph. Like this one graph has been made it like 0 to 1 is going 1 to 3, 3 to 5, and like this graph has been made it like 0 to 1, and here I wrote it the 4 like you have seen, and then it is giving going to 1 to 3, and it is written the 10 like that, and then here 1 3 to 5 it is going and 11 is written here, and then it is 4 to 3 is going and here 4 is written, and that 2 to 3 2 to 4 is going and here 3 is rotated, and it is going 0 to 2 and 2 is rotated here, and it is going 1 to 2 and 5 is rotated here like that. Now let me give you one example of this straw algorithm. Like this one algorithm is made it like 6 to 1, then here 14 is rotated like 0 and A, and then 1 to 2 is going this 1, then 9, like 1 to 3 is going 6 to 3, here's 2 is rotating, 6 to 5 is going, 9 is rotated like that. Here you can see it. Now let me erase it. Now here you can see this type of one graph has been made it. Number first is mark all nodes unvisited. Create a set of all unvisited nodes called the unvisited set. Assign to every node a tentative distance value. Set it to 0 for our initial node and to infinity for all other nodes. Set the initial node as current 16. Number 3. For the current node, consider all of its unvisited neighbors and calculate their tentative distance through the current node. Compare the newly calculated tentative distance to the current assigned value and assign the smaller one. For example, if the current node is marked with the distance of 6 and age connecting it with a neighbor B has length 2, then the distance to B through A will be 6 plus 2 equals to 8. If B was previously marked with a distance greater than 8, then change it to 8, otherwise the current value will be kept. Number 4. When we are done considering all of the unvisited neighbors of the current node, mark the current node as visited and remove it from the unvisited set. Visited node will never be checked again. If the destination node has been marked visited when planning a route between two specific nodes, or if the smallest tentative distance among the nodes in the unvisited set is infinity, when planning a complete traversal occurs when there is no connection and between the initial node and remaining unvisited nodes, then stop. The algorithm has finished. Number 6. Otherwise, select the unvisited node that is marked with smallest tentative distance. Set it as the new current node and go back to step 3. So here you can see it. In today's video, I told you about what are shortest paths in Python DSS. So here you can see it very easily as I have told you. So you must know what are shortest paths in Python DSA. You must know that, okay? And here you can see it. In today's video, I told you about what are shortest paths in Python DSA like that. So here you can see it. I hope you can enjoy this class. I appreciate your support. If you genuinely appreciate my work, so please let your friends know this course about too. And if you haven't checked my whole playlist yet, so move on to the code.pk.com on my YouTube channel so you can easily access it and bookmark it also. So now I'm in next class and next very amazing class like that type of video. So now for today, goodbye.